Hey Nighthawks, this is Module 5, Lesson 11. In this lesson, we are going to look at equivalent fractions with our area models, with our tape diagrams and number lines to show equivalence. So our objective is I will be able to explain fraction equivalence using a tape diagram and the number line and relate that to the use of multiplication and division. So really similar to what we've been doing with the area model, saying, well, if I have 1/3 and I decompose it into 2 rows, I now have 2/6, and we are able to show that with a multiplication sentence. We're going to do something very similar, but with tape diagrams and number lines. So here's our first tape diagram, and our number line is right below it. So if you see here, this is our 1 whole, okay? And you can see one of those units is shaded. So what this tape diagram is representing is 1/4. So to type in your fractions, you're going to double click on the top and the bottom, double click. So you can see there's 1/4. If this one were to be shaded, this one would be 2/4. Oh, excuse me. This one is 1. I put that one a little bit too soon. This would be 0 because it's at the end of our tape diagram. And then halfway would be 2, 4, 3, 4, and 4. So this is our number line. So our shaded portion goes up to 1/4. So it says circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. So because our 1/4 is what's represented in the tape diagram, that is what we're going to circle is 1/4. Okay, so we're going to do this to 2 more number lines and tape diagrams, but all of these are going to have something, they're all going to be equivalent. And I want you to see if you can catch on to that, okay? So now let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8. So this is broken into 8s. So all of our fractional parts on the number line are going to have a denominator of 8. We start with 0, because if I was at the very end of this, I wouldn't have any value. 1, 2, 6, 7, 8. And our denominator is going to all be 8s. Okay, so then same thing. Here is our number line, and it lines up with where we have 2 8s as our fractional that's shaded, fractional unit that is shaded. On our number line, our 2 8s matches. So we're going to circle 2 8s. So now remember, this one I had 1/4. Now we have 2 8s. Are those equivalent? I want you to be thinking about that in your head. Can we show that those two are equivalent with multiplication or division? Okay, so we're going to do one more, and we'll look at that even deeper. So I've got 3 that are shaded. Let's see what our fractional unit is broken into. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our denominator is going to be 12ths. Our numerator just kind of counts over. Remember, you start with 0. There's our numerators. You can kind of already see we're going to have 3 12ths, right? Because we're working with 12ths. Remember, if this takes too much time for you, especially if you don't have a mouse, You can draw these out on paper, write them out on paper, and send me a picture when you guys are doing it on. So now let's see what fractional or what fraction is labeling the point on the number line. So if we see that our 3 are shaded, then we are going to want to circle our 3/12. Okay. So in the next portion, we're going to talk about all three of these equations, or these, excuse me, fractions. We had 1/4, 2/8, 3/12. So I want you to be thinking about that as we go down here to our next slide. It's going to ask us about those questions. So the fraction represented in 1a is equivalent to the fraction represented in 1b. So in 1a, we had 1/4, and in 1b, we have 2/8. So how can we show that that is true? And I'm going to enter a text box to allow us to type. So I just click that little T and then put it where I want to type. So we can say 1/4 is equal to 2/8. How can we show that that is true? If we wanted to show multiplication, just like we've done before, right? So 1 times what would give us 2? We would take 1 times 2 is equal to 2. And then if we wanted to do our denominator, we would take 4 times 2. And that would prove that that is equal to 2/8. So our numerator of 1 times 2 gave me 2/8. 4 times 2 gave me 8. 1 times 2 gave me 2, not 2/8. 4 times 2 gave me 8. So because it said write number sentences using multiplication to show. So that's all you would have to do. 1/4 is equal to 2/8. Let me show you how with that multiplication. 1a and 1c. So 1a, we still had, oh, there's the numbers down there. Guess if I just scroll down, I could show you. That's okay. Typing is a little bit easier than clicking and dragging. So 1a, we had 1/4. And 1c, we had 3/12. So how can we show that that is equivalent using multiplication? So if we think of multiplication, 4 times what gets me 12, 1 times what gets me 3, whatever we do to the bottom, we're going to have to do to the top. So we can prove by multiplying our numerator and denominator by the same number. So 1 times what gets me 3? 1 times 3. And then 1, oops. 4 times 3. Oh my goodness, you guys. 4 times 3. I made that 3 up top backwards. I don't know if you can see it or not. And then 4 times 3 gives us 12. So all of these, so if 1/4 is equivalent to 2/8, is 2/8 equivalent to 3/12? If you look at it on our number line, they are technically the same. Because they're, if you can kind of see off to the side, they're all shading in the same portion of the tape diagram. They're just decomposed more and more and more. So 1/4 is equal to 2/8 and is equal to 3/12. So when you guys do that, it may ask you to decompose it even more. So I'm going to do this one with you. I'm not going to go through all of them. But it may ask you to decompose into a certain amount. So it says, use this shaded tape diagram as a ruler to draw a number line. mark each number line with the fractional units shown on the tape diagram. So if we use this to kind of draw that number line down below, and then you're going to want to use these as kind of your point markers at the beginning and where your shaded portions lie on your tape diagram. Just like that. So then you could say we have 1, 2, 3. So we would have 0 thirds. And then this one would be 1/3. This one would be 2/3. And 3/3. So 3/3 or 4/4 or 5/5 would be equal to 1 whole. So if I had 3/3, that whole tape diagram would be shaded in, which means I have 1 whole. I brought that up before. If I were to ask you how many fifths do I need to make a whole? You need 5. How many eighths do I need to make a whole? I would need 8. So understanding that whatever my denominator is, that's how many I would need to make 1 whole. Okay. All right, you guys. Number lines and tape diagrams will help us understand these fractions a little bit more, and we will work with them in the next couple lessons as well. All right. Great job today. Remember, I'm always here if you have questions, and we'll see you guys soon.